Before releasing Season 2 of the hit podcast Testing 123, we subjected it to a rigorous series of tests. It's been kicked, prodded, shaken, frozen to near absolute zero, placed 26th in line for the next available customer care representative. So after zapping it, dropping it, poking it, and locking it in a cage of hungry ferrets, we are proud to announce Season 2 of Testing 123 is ready. It will be ready. So look for Season 2 of Testing 123 wherever you get your podcasts.
Our meeting is about to begin. Please take your seats. Our meeting will begin in 10 minutes. Please take your seats. Our meeting is about to begin. Please take your seats.
Ladies and gentlemen, there are seats on the left side of the room. Ladies and gentlemen, there is additional seating on the left side of the room.
Our meeting will begin in 5 minutes. Please take your seats. Our meeting is about to begin. Please take your seats.
Ladies and gentlemen, there's an additional seating on the left side of the room.
Please take your seats. As a courtesy, we ask that you place all wireless devices on silent. Our meeting is about to begin. Please take your seats.
Performance. It's what separates the winners from the rest. Those who perform at the highest level are the ones who make history and shatter the status quo. But what is the key to better performance? What makes a product smarter, faster, stronger, more reliable? The answer lies in your test data. By tapping into the vast power of test data and advanced analytics, NI helps you discover insights that supercharge the quality of your products and drive countless efficiencies across your organization. Less downtime, fewer defects, greater scalability. Some might say it's a bold concept, rethinking test as a way to boost the performance of today's complex products and the businesses that create them. We simply see it as another way NI is committed to engineering your success.
Ladies and gentlemen, please welcome to the stage NI CTO Thomas Benjamin.
Hello everyone, welcome to the PM Keynote for NI Connect 2022. We are so excited to be here in person with many of you and streaming this online to thousands across the globe. This morning, you saw Eric talk about opportunities to add value to customers through measurement and measurement data. Let's take a deeper look at why this is important to help customers in making them better in getting better operational and engineering performance in the industrial space using test and measurement. As we've evolved to the next level of digital maturity, there's been a significant increase in complexity of systems. The move from 4G to 5G to wireless in the wireless space, the move from 5th to 6th generation fighters in the aerospace and defense, and the move to autonomy in transportation, and the proliferation of intelligent connected electronics with the rise of IoT devices. Customers today want higher performance products that essentially deliver faster to market at lower cost with fewer to zero defects. They feel that they've optimized test incrementally but not exponentially, and they're looking for the next frontier of innovation in test and measurement. At NI, we think the next meaningful advancement is the ability to add value to customers by fusing the concept of physical and behavioral model-based testing and measurement with data-based testing and measurement. What does this actually mean? Data-based testing and measurement helps a customer move in the direction from manual to descriptive and diagnostic insights and analytics, which leads to prescriptive and predictive insights and analytics, and eventually to intelligent, hyper-automated systems. Another concept is model-based testing and measurement. Many of you are already modeling and simulating heavily using modeling and simulation in developing your products. Moving more of the design into the virtual world allows you to iterate, explore complex designs faster, and reduce the dependence on costly, time-consuming prototypes that you have to build. Many of you want to accelerate this shift-left journey to be able to help move faster cycles of production and delivery. And in NI's vision, we feel that the concept of bringing in automated test and measurement by bringing in physical models and designs along with data-driven systems is where the future of testing and measurements goes. The journey to move along this direction lies in this fusion that we at NI are beginning to kind of foster and push forward. And today you're going to see a number of customers who are going to be in different phases of their development as they go through this cycle, show about examples of how they are able to move this journey and trying to fuse physical systems, models, as well as data-driven systems and model, because this combination is what is going to give them the ability to build high-performance product faster with higher quality. In any manufacturing process that extends from design to production to validation and in-use, NI has the tools and capabilities to help you wherever you are in the spectrum today to move along this journey. And you're going to see some of these examples today. But the journey starts with a simple step. And the step starts with acquiring data, analyzing data, and acting upon the data. Our first story starts with a company from Ireland. EI Electronics has been in manufacturing life-saving devices for many decades. But recently, they have had an explosive growth due to technology evolution. Let's hear their story before we bring them online.
EI Electronics makes life safety products, smoke alarms, carbon monoxide alarms. Basically, we're a sensor is our basic technology, and quality is absolutely essential. It's not an option. My name is Michael Guinea, better known as Mick, and I'm the chief executive of EI Electronics. We started out in 1988, and building regulations in the UK began to become favourable about 1992. So our business was now beginning to grow. We had a lot of different models of products now, and our manufacturing process was beginning to get complicated. Our products are evolving. We started out with a smoke alarm, then a carbon monoxide alarm. We are now a constituent part of the Internet of Things because our sensors are in the home, the data is coming out of the home, and so on. So our products now are not only have to function, but they've got to provide data. Up to the recent years, we would have designed our products in isolation, maybe from the test guys, then the product was given to the test guys to come up with a test platform for the thing. With the standardization now, the guys from the product design are integrating very much from the beginning with the test guys. Expanding in test in previous years was a horror show because we had so many different things going on. So standardizing it just makes it much simpler to be able to do it. So that's been a big change. Standardizing just so much common sense, but it took us a long time to get there.
Now, to help us learn more, please welcome Joe Daly and Paul Kilbridge from EI Electronics. Hey guys, welcome.
Thanks, Thomas. Thank you.
Welcome, guys. Thank you for making this trip. We just saw your CEO introduce the importance of test and standardization at EI. Can you tell us a little bit more about the path that you guys are on?
Yeah, sure, Thomas. So our journey is similar to many IoT manufacturers. It's a story of complexity, quality, and of course, volume. A few years ago, a fire alarm was a device with 9-volt battery, a sensor, and a buzzer. Today, the device has embedded software, multiple wireless functionalities, and an interactive user interface. You probably have one or two such devices in your house. European regulations now demand the installation of a device in almost every room in your house. So this rapid growth, while very welcome, places great demand on our business. We are addressing this in 3 stages: automation of methods, system standardization, and digitalization through a connected factory.
It all starts with automation. I work in our validation team, where we face ever more complex products from our design team and ever faster schedules to test them. We will never sacrifice quality due to the life-saving nature of our products. And to meet the requirements of this new test coverage, we've turned to automation using LabVIEW and PXI. Our manager jokes that LabVIEW is the only engineer in the company that works on 3 shifts. When we go home, he keeps testing, running through thousands of scenarios, waiting to give insights the next morning. Automation of these validation tests has saved us 50% of time per project when compared to our previous strategy.
So next is standardization. 5 years ago, we had over 60 production cells running hundreds of bespoke customized testers. These unique designs had unpredictability, design times, build costs, and of course, schedules deliveries. The strategy quickly became unsustainable. This is where NI comes in. We've worked with them to design a common hardware and software platform. We chose NI as the breadth of tools available gives us the confidence that we can meet our test and business needs now and in the future. But of course, tools aren't everything, as so much of standardization is process and proficiency related. The project is ours to lead, but NI supports us beyond just technical information. They are our partner in this journey. So with this standard platform, along with purposeful recruiting, strong change management, and a culture that promotes personal development, we are achieving real success. We have drastically improved the development of our testers from months to weeks, as well as improving yield by 20% and cycle time reduction by 50%.
What's more is we've standardized across the design life cycle. My team now shares ideas and code with product engineers. This helps with both quality and drastically improves development times.
Now, you guys should be really proud about what you have accomplished. What's next for you?
Yeah, so next stage is test standardization, as you know, has tangible and financial benefits today, but what really excites us is how it prepares the ground for digital transformation. Digital technology will have as big an impact on manufacturing as Six Sigma did in the past. Getting real-time insight and information into the operation of every production cell is the key to optimizing them. Step 1 is implementing a standardized set of processes, systems, and data. Without this, we will have a difficult road ahead of us.
And connectivity and digitalization aren't just for manufacturing efficiency. In R&D, I want every prototype that passes through my lab to have a digital passport. It logs every result and every interaction on a digitally connected thread of information. For example, if a PCBA is dropped or if a power line is overloaded, it may look the same but behave differently in subsequent tests. If we don't track these human events, we'll never know if the design is at fault or if it's just some human error. And we, in the past, have spent days, if not weeks, investigating what we call these phantom events. A digital thread would allow us to look holistically across the whole validation path, eliminate this wasted time, and make better, more qualified decisions about our product's performance.
So the investment at EI right now is obviously focused heavily on new technology, driving product and process performance. If we don't invest now, we won't be able to deliver in the future. And this is why it's a time for engineering investment.
Paul and Joe, thank you very much for sharing your journey with us, and wish you the very best as you kind of continue into the next phase of technology evolution. Thank you, guys.
Thank you so much.
Our next story comes from a company that most of you are very familiar with. Nvidia is an engineering-led company that is one of the most innovative in the market and has changed the way in which we use computers. To tell us more about their story, please welcome Arnold Suratos from Nvidia. Welcome, Arnold.
Yeah, thanks for having me.
Now, Nvidia has been using NI's Optimal Plus in combination with other technologies to create massive breakthroughs in operational performance, including quality, yield, efficiency, and ecosystem excellence. For those unfamiliar with NI's Optimal Plus, it is a full lifecycle analytics platform that NI acquired in 2020 that helps customers improve reliability, yield, productivity, and efficiency across the manufacturing process. So Arnold, can you tell us a little bit about the history that you've had with NI?
Sure, I'll be happy to. So NVIDIA started as a fabless company, fabless chip company. It grew to a platform company where we now also design and build boards and system products. We started using the NI Optimal Plus back in 2012 for our semi or chip business. In 2017, we partnered with NI All Plus to expand the data platform solution to cover boards and modules. Then in 2020, the same solution was adopted for data center products. These developments are the foundation to what we call the Contract Manufacturing Management Solution, which is a joint effort between our operations engineering teams in NVIDIA and NI All Plus teams.
Now, what were some of the factors you were dealing with when you worked with NI to help create the solution?
So as we grow our business, we increase our engagement with different contract manufacturers. This presented challenges with maximizing productivity, efficiency, yield, and quality. We needed to innovate and be creative in allocating our engineering resources by working smarter. We want our contract manufacturers to build and deliver our products expeditiously and continue to improve yield and quality. To do this, we need to automate complex processes that will help our CMs in order to execute and deliver anything that is impacted by any issues. This involves like setting up capability to automatically send out early warning signals that help us act much faster before serious issues even arise. We wanted to do all of that while still improving the productivity, efficiency, yield, and quality.
Now, from what I understand, the architecture of what we have in place looks something like this, where we are collecting data from the contract manufacturers into the NI's product analytics cloud and providing NVIDIA with data, analytics, and insights to make better decisions. Arnold, can you go deeper a little bit and give us some more details about the specifics of how you manage your contract manufacturers and what are the new capabilities that you had to introduce into the solution?
Absolutely. To better understand that, let's first look at how we used to do it. In the past, we used the NI Analytics platform to collect data from the CMs and then provide reports to the engineers at NVIDIA to help them understand the issues and challenges at each CM. Anytime that they find issues, they would reach out to the individual CM via email or some other time-consuming methods to help fix those issues. This was not efficient and scalable to manage an ever-increasing amount of contract manufacturers. Additionally, it was difficult to track whether the issues were even resolved or not. To address this, we introduced two very powerful capabilities. First, we created pretty much our version of Tony Stark's Jarvis. We call it the virtual engineer, by using rules and machine learning to replicate what an actual engineer might do. We had to very creatively and carefully create these rules to minimize what we call like false positives and ensure that when an alert happens, it is meaningful and accurate. The second capability is to automate the interaction between the virtual engineer and the CM. By doing this, we are able to track all the actions up to completion. This way, we know that issues are resolved, how they were resolved, and how long they took to resolve. By doing that, we are improving the quality and performance, not only of our products, but also the performance of our contract manufacturers.
So it's been only about 6 to 8 months since you have implemented this. Have you seen any results yet?
Oh, it's amazing. In the short time that we have been using it, this system, along with a few other initiatives that we're working on, we have seen significant increase in efficiency, productivity, quality, and yield. Additionally, we were able to reassign 35% of the resources, as in the technical resources, that we use, that need to manage the contract manufacturers, and then they are then allocated to do more technical and manual tasks. I mean, more that will need more engineering, like expertise. While some of these numbers may look small or to those that are unfamiliar with the manufacturing. These seemingly small numbers or improvements actually translate to millions of dollars in savings. And lastly, while NIO Plus wasn't we wouldn't say that this whole improvement was because of NIO Plus, but significantly because of our partnership, it was a major contributor to this success.
This is truly an inspirational story. It talks about the power of data and analytics to make a holistic improvement in your entire process, essentially. Thank you for sharing it with us today, Arnold. And good luck in your journey forward.
Thank you.
What we've seen today is just the beginning of what is really possible when we rethink the value of test and use the latest technology and analytics and data to drive performance at all levels of an organization. We want to realize this vision by listening to our data and providing you the best opportunity to get the most value out of the insights obtained from the data. I wanted to provide you a little bit more insights into some of the other capabilities that's coming down the pipeline at NI to help improve for the customer reliability, yield, quality in your own process. It all starts with 45 years of experience in the test and measurement space, where data coming out of our test and measurement systems can be streamed into a TCO-optimized data repository that is secure, resilient, and always available to all our products and systems. We surround this data repository with a set of reusable microservices that can be leveraged across our product portfolio to deliver newer capabilities faster, staying responsive to the needs of our customers in this agile world. This is what we call the core of our software platform. All our software products and capabilities are built on this platform, which gives you the advantages of a platform-based approach to product development. All these capabilities are available to you as APIs or standard integration patterns so that you can extend them to meet any specific requirements or corner cases that you have. All the software building block that we are developing here are designed to run in your private data center or in a public cloud, depending on the needs that you have at your end. Now, if I unpeel this layer another level deeper, we have taken this modular approach of putting this platform together. It's like a block of Legos that can be put in a certain combination to answer the needs of a certain set of customers, seamlessly synergizing with what you already have in your ecosystem today. The core of this platform is the data ingestion service that helps us ingest data from all your connected systems for meaningful analysis. Once the data is ingested, it is persisted in a TCO-optimized manner with the right data persistence services, whether it's time series data, waveform data, or parametric data, and other future data formats that you can plug into this architecture. The analytical and ML engine gives you the ability to leverage insights from our templatized model with the flexibility for you to bring your own models and plug them into this architecture. The visualization layer that we have here is connected to or embedded with standard BI tools that you're very familiar with. And the UI framework layer acts as a glue, bringing all this together with a very simple UI experience. The core of the platform uses security frameworks, resiliency frameworks, and DevOps tools to be able to deploy products in a simple, elegant, and lightweight manner, both in your data center or in the cloud. And every aspect of this modular architecture is extensible through APIs. Now, this is a 100,000 view of it. Let me unpeel this another layer further. Now, this chart is going to look like a very heavy chart, and it is intentionally meant to be a heavy chart to show you the level that NI is going to hide this complexity from each and every one of you so that you can choose to integrate into this ecosystem using APIs and other integration patterns so that it can coexist with what you already have today. Let me double-click into some specific areas. The data persistence service, we use polyglot persistence so that we can use the right persistence store for your workload characteristics, whether it's SQL, NoSQL, object stores, in a TCO-optimized manner. The analytics and ML layer is made up of a collection of ML frameworks like Kubeflow, Spark, RStudio, that you can use to build your own machine learning models Also, we would provide a bunch of models that come templatized to democratize some of the best practices that we get in the industry. On the analytics tool side, we wanted to give you the choice of the analytic tools that you're familiar with. So we have embedding tools like MicroStrategy to start with, and later on Tableau and Power BI, so that you can innovate with the tools that you're familiar with on this platform. And of course, the platform core services has a set of capabilities like security frameworks to do encryption, bring your own keys, Docker and Kubernetes to be able to deploy in an agile and lean manner, either in your data center or in the cloud. And of course, the UI framework is a simple UI framework made up of Angular and other building blocks to give you a simplified UI experience, either in any browser or on a mobile device. And every layer of this platform is available to integrate, extend through APIs. Now let's take it back another 100,000 feet of this platform and look at the simplified architecture. This is the model that we want to give you that can blend into your system. It's using this model, we've actually built an application for wafer classification, and I want to talk about that in a minute. One step in the semiconductor wafer manufacturing process is called wafer sort. In this step, the wafer is tested electronically using an automatic test equipment. Following this step, the engineers today visually analyze the wafer for defects. What NI has done on this platform is that we've built a software that automates the process of analyzing the wafer and identifying patterns of bad quality wafer as shown in the chart below. The automated software does post-wafer sort clarification step much, much faster. It's deterministic, consistent, and greatly reduces manual errors. It also helps detect granular patterns much more accurately. The advantages to you are you increase productivity by focusing on solving the problem rather than looking for them. You can rely on NI's cumulative knowledge gained through processing 100 billion dies a year for the last 15 years. By finding the best dies, you can optimize yield by binning or routing the best dies to segments of the market which have the most stringent requirements. You can also detect many systemic problems that you are not able to do manually. Also, because wafer classification is a solution that's being offered as a SaaS solution, it is easier to access and onboard and coexist with any product or analytics solution that you're using today. We are planning to release this version in Q4 on this platform that I just showed you that would include a few templatized wafer classification algorithms. And in future, we would allow you to have the flexibility to build your own algorithms for wafer classification. So this is one more example of how we make life better for our customers by helping them listen to their data. Data is just one part of this equation. Physical behavioral models are the next part. To guide us through the next part, I'd like to welcome to the stage Charles Schroeder, NI Fellow. Welcome, Charles.
Thanks, Thomas. So as Thomas mentioned earlier in his keynote today, many of you, our customers, are looking to go beyond incremental improvements to real exponential impacts in both your product performance and in your business results. Now, based on NI's 45-year history of building some of the best automated, standardized test systems on the planet, companies like Nvidia are able to leverage NI's measurement hardware and measurement data and vast amounts of that data combined with product analytics to achieve really breakthrough business results for their company. Now, beyond product analytics, though, there is another tool that many of you are beginning to employ to also achieve these breakthrough capabilities in product performance and business results. And Dr. Meyer this morning referred to the term digital engineering. This is a term often used to describe model-based system engineering practices that are increasingly allowing you, our customers, to design and validate your products in a virtual world. And in combining NI's measurement technology and measurement data with industry-leading software from modeling and simulation companies, in the future, we will be able to build increasingly capable models of our products, of your test systems, and of the environment in which they will all operate, with the goal of significantly improving those business results yet again. And this is not just a dream. This is on the horizon, and we have thought leaders today that are already beginning to adopt some of these model-based system engineering and digital practices to weave consistent digital threads of truth throughout their entire design process. And by having these digital anchors, which are consistent in every element of design, we can begin to increasingly automate very sophisticated processes that help us make those improvements in product performance and in our business results. Space has always been the final frontier, right? And I think we can all agree that in recent years, there has been tremendous progress in making space far more accessible. One company, Firefly Aerospace, is working with NI Alliance partner Tech 180 to embrace model-based engineering practices to help them ensure their goal of an orbital launch later this year.
Commit for launch.
Achieving first flight is a huge milestone for a rocket company.
3, 2, 1.
But ultimately, this business is about getting to orbit and doing it repeatedly. We did learn a lot from the first flight. We fixed the minor problems and are ready to get back to the launch pad. What has impressed me most is the growth of the team. When we tested the first flight vehicle, it took us over 18 times to get it fully functional. In getting ready for this second flight, both the vehicle and the team performed flawlessly on the first attempt. We've gotten smarter, faster, and more disciplined.
Made it all the way.
We are ready for orbit. See you at the launch pad.
All right, so to tell us more about how these model-based technologies are ensuring their mission readiness, please help welcome Joseph Marlin from Firefly Aerospace and Chris Bakker from Tech 180. All right, so Joseph, tell us, Firefly, space, this must be exciting. Tell us about your company.
Yeah, well, as you saw in the video, Firefly is getting ready for our next orbital test launch. But getting to orbit is really only part of what our goal is, to provide end-to-end space transportation services. So along with our first Alpha orbit, we're also preparing for surface operations on the moon with our NASA-sponsored Blue Ghost lunar lander. And we're pioneering in-space mobility with our SUV Space Tug. This diversification really sets us apart in the industry because it allows us to lower costs for customers, and that allows us to provide unprecedented access to space. That's why our motto is making space for everyone. But space is one of the most challenging environments to operate in, with periods of highly varying temperatures, extreme vibration, huge acceleration, and on top of that, intense solar radiation. With these critical missions on the line, we need to be able to make sure that our flight hardware operates reliably and consistently. And that's why it's so key that we have these test solutions that allow us to adequately characterize our flight hardware on the ground. And to do that, we are relying on NI partner Tech 180.
At Tech 180, our mission is to accelerate engineering in aerospace by breaking the serial dependency between having to know everything about your product before you can build the test infrastructure. So we use model-based engineering to allow us to design and build test equipment in an agile way, using an NI-based solution we call System on Demand. Now, System on Demand starts with understanding the product we're trying to test and the interface to the world around it. Whether it's a single product or an entire system, that interface defines the specs and capabilities that are required in the test system. And from just that information, Tech 180 can generate a complete virtual model of the test system using 100% modular components. So if the product requirements happen to change, which they never do, but just in case, we can update the design again and again in an iterative, agile process. And with each iteration, we can auto-generate the time-consuming deliverables that are going to kill your schedule when the product is still in flux. So all of this allows us to develop the test system in conjunction with the product and then rapidly manufacture it to get it into your lab on schedule. Joseph, can you tell the audience how this is impacting your team?
Yes, Firefly is a space and launch services company. We do love vertical integration, but building test racks isn't really our core competency. By using this system on demand, we're able to empower the experts in test to do what they do best, so that we can keep building rockets and spacecraft, which is our true passion. At Firefly, we've really enabled our engineers to take full ownership of the systems they're responsible for. And that means that they often work quickly and iteratively to really drive that innovation. For example, as the details of our lunar lander Avionics have matured, we have notified Tech 180 of 72 changes to our avionics design. Despite that, we have still saved 3 months in our project timeline by using this system on demand, a significant percentage of our 2-year mission. And thanks to this algorithmic design from Tech 180, only 6 of these 72 changes have required change orders. This rapid development that we're enabled to do is a competitive advantage for us in the space industry, but it does make it challenging to ensure that the support equipment for our flight hardware is available at the same time, and we're ready to start testing. But Tech 180 has been able to dynamically leverage the NI equipment to make sure that as we've refined our design, we can continually iterate on it, but still at the same time keep that support equipment in lockstep.
Yeah, I mean, it's really kind of impressive results with the number of changes that are just natural, that you can keep up with that and actually come in ahead of schedule. So tell us, how are models helping ensure your mission readiness and staying on schedule at the same time?
Well, today, the exchange of requirements is still largely being done through verbal communication and non-standard formats like spreadsheets. But behind the scenes, Tech 180 has taken those requirements and putting them into a model-based format that can be incorporated directly into a customer's digital workflow. So in the future, you won't even need to specify a test system. We'll be able to continuously integrate the test system design in real time as the product models are updated. Now, already today, a Tech 180 system can read its own configuration, automatically generate a script that verifies that it meets its requirements and links that back to the original model. That's how we close the digital thread. But that's not even the cool part. In the future, as a customer's product model becomes more mature, we'll be able to use the same technique to automatically generate the product test scripts. And again, link that back to a single source of truth. And not just in validation, but in any test system across the life cycle. But wherever you are in your digital transformation today, a Tech 180 system can still reduce cost, schedule, and risk today, and that's always a good thing. But you'll be confident that you're working on an architecture that's ready for what's next.
So speaking of what's next, Joseph, what's next for Firefly?
Well, next up for Firefly, we do have that Alpha launch number 2. And close behind that is our Alpha Flight 3, which is our first commercial payload. In the meantime, the spacecraft division is laser focused on preparing for our test readiness review in December, where we verify that with NASA that our lunar lander is completed build and ready for integrated testing.
So I think this is, I mean, I love space anyways. I think what you guys are doing is inspirational to all of us. We're going to be following you guys very, very closely in the news throughout your success. I want to wish you and your team the very best of luck as you guys make space for everyone. Thank you very much for your time today. Thanks, So we just saw a great example of how using requirements and ultimately models of our products and how that can lead to new levels of automation that can bring incredibly sophisticated products like rockets to market much faster than we expected. Another trend affecting test is the increased use of artificial intelligence and machine learning to define the features of a product itself. Now, this incorporation of trained rather than designed behavior is creating all new challenges for design and for test engineers. Put simply, having accurate models of your system and their environment are absolutely crucial going forward in the future. So to learn more about how Samsung is using artificial intelligence and machine learning in the design of their next generation wireless networking equipment, please help me welcome to the stage Dr. Sunghyun Choi from Samsung Research. All right, so it wasn't that long ago that I got my 5G phone.
So ever since the first mobile telephone call in the early 70s, the last 5 decades have produced a revolution in the advancement of mobile communication. Although it might look like we're just getting 5G now, we at Samsung Research are already working on 6G. Each generation of wireless technology takes about a decade to develop, and we are working towards 6G deployments by 2030. With all the capabilities of 5G, it can be hard to imagine what's next. Thus, I would like to highlight 2 mega trends that will define 6G technology and use cases. First, consider that by 2030, there will be more than 500 billion machines connected to the internet. This will be more than 60 times the world population then, and these machines drive different technical requirements than connecting people. Second, consider that the rapid maturization of AI ML technology in both consumer and enterprise applications. 6G mobile networks will use AI ML in a range of ways, from network planning to optimization of radio RF front end. In the future, mobile will enable new applications for hyper-connected experiences, experiences like truly immersive extended reality, high-fidelity mobile holograms, and even digital replicas. These applications create new technical requirements for 6G. Examples include expanding peak data rates up to 1 terabits per second, while reducing the air latency down to 100 microseconds.
Yeah, it's going to be fun, isn't it?
Yeah.
So what types of technical innovations are going to be necessary to meet these new performance requirements?
Well, to meet these requirements, 6G is likely to employ a wide range of candidate technologies. For example, just as the need for more network capacity has pushed 5G to millimeter wave bands like 28 gigahertz, 6G could push into terahertz or sub-terahertz bands beyond 100 gigahertz. To address signal propagation issues at these frequencies, 6G will also need to evolve antenna and beamforming technologies to overcome the massive path loss. Although there are many areas of study for 6G research, one of those that is most exciting is the use of AI and ML. For example, let's take a look at one of the classic challenges in wireless. That is, wireless signal strength decreases over distance. Although higher power signals can travel longer distances, there are practical limitations to a device producing a high quality and high power signal in a cost-effective manner. If you are familiar with audio applications, you probably observed that the sound can become distorted when you turn up the volume. The same is true for a mobile device RF amplifier. Merely driving up the power level can distort the uplink signal and prevent it from being decoded at the base station. As a result, mobile devices actually back off the transmission power in practical use. This ensures transmission of a clean signal. Because of this, there are several techniques that system designers can use to maximize throughput over distance. One option is to use an amplifier that is capable of distortion-free transmission at higher power levels. Although this enables propagation over longer distances, such an amplifier is typically too expensive for practical use. A second option is to reduce the power of the transmission to reduce distortion. However, by doing so, we limit transmission distance of the system. A final option is to drive the amplifier deep into compression, thus allowing for a distorted output.
Yes, so now you've got a highly distorted system, and we need to make some sense out of that. So how can artificial intelligence and machine learning help the problem?
Right, so we are exploring techniques that use AI ML technology to correct for distortion at the base station. One of our recent innovations is a technology that we refer to as AI-based nonlinearity compensator, or AI-NC. With this approach, we use an AI algorithm that allows the base station to learn distortion patterns of the mobile transmitter by first receiving a reference signal from the mobile. This algorithm is able to effectively reverse engineer distortion caused by the amplifier and correct the received signal. Note that the distortion pattern should be dependent on the mobile device. The beauty of our engine is that the AI model is trained during the runtime adaptively for each mobile device. Using this approach, we can sustain higher data rates over long distance, better utilize spectrum, and improve power consumption of the mobile device.
Yeah, so I know that your team is familiar in using a number of the NI software-defined radios. So can you talk a little bit about how you use the USRP products to help in this work?
Mm-hmm. So NI's USRP software-defined radio allows us to test our ideas in the real network using a testbed. In this testbed, the SDR emulates the radio portion of both of the mobile device and the base station. For example, in the base station's receive chain, SDR first receives a signal from the mobile device. The waveform is first equalized and then passed through Samsung's proprietary AI engine. The AI engine reconstructs the jumbled waveform so that it can be demodulated in a usable bitstream. Using this technique, even extremely dense communications waveforms can be demodulated. Note that one of the benefits of NI's SDR is the flexibility. This platform allows us to easily test various configurations across multiple types of antennas and also waveforms. We've already been able to demonstrate a 1.9 times improvement in transmission distance, and we'd like to keep improving.
Yeah, so I think it's incredible. I mean, I think you give us a little bit of a glimpse into the future here, and your team has just done fantastic work. And I want to emphasize the point. How many of you would like your high data rates to go twice as far as they go today? I mean, this is going to be incredibly impactful for our industry. And from talking to you offline, I also know how much this is going to scale to even more advanced waveforms in the future.
Right.
So thank you very much, Dr. Choi. Appreciate it.
Thank you. Thank you.
All right, so to help us in the next part of the keynote, I'd like to bring back to the stage Thomas Benjamin.
Thank you, Charles. In the next section today, we want to revisit the exciting area of rocketry. In improving performance over time, we need to be aware of the next generation of engineers that are coming up and some of the things that they're doing. You will see their rocket in the experience hall, and to celebrate them and hear their perspective of things, we'd like to welcome on stage Urvi and Greg from TREL, UT Austin. Welcome, guys. Urvi and Greg, tell us a little about what you guys are doing.
At UT Austin, we say what starts here changes the world. But at the Texas Rocket Engineering Lab, or as we call it TREL, we say what starts here changes worlds. Not only are we attempting to be the first students to launch a liquid bipropellant rocket to space, but we are also making the dream of space a reality for us, a group of students who never thought it possible. I'm Urvi, and I'm a second-year aerospace engineering major and the director of operations for TREL.
And I'm Greg, a third-year aerospace engineering major and TREL's corporate development lead. We are here today to tell you about how NI's technology propelled our department project into an industry-level lab, building the most advanced collegiate rocket to date. Halcyon is our 30-foot-tall rocket that we will launch to the edge of space, aka the Kármán line, which is the same distance Jeff Bezos flew with Blue Origin. To no surprise at all, we've learned that sending a rocket to space cannot be done without extensive testing and valuable partners like NI.
There are three main aspects of a rocket that set us apart from other collegiate groups: our usage of COPVs, or composite overwrap pressure vessels, HIL, or hardware-in-the-loop testing, and our regeneratively cooled engine. NI has been a key collaborator in all three of these distinguishing qualities, allowing us to effectively test and burst our vessels and program test sequences to collect critical data to validate our systems and improve product performance. Using NI hardware and software, namely VeriStand and LabVIEW, our HIL team writes emulators and simulations to test our flight computer and mission control system software. This reduces the burden on the system architect and allows us to focus on function over form, prioritizing reliability and stability in our product performance.
Through our partnership with NI, we are turning our dreams into reality. NI provides us with scalable solutions for multiple types of tests. Nothing better demonstrates this than our completion of 4 successful hot fires of our 2,000-pound force proof of concept engine, TXE1. Only 7 universities have successfully completed a liquid bipropellant heatsink test, and now UT is the newest member of this elite club.
Thanks to NI, 19-year-olds like me are becoming better engineers and learning and applying the concepts of models and data today to improve product performance in the future. We're excited to continue this partnership with NI as we aim for our official launch in 2024. Thank you, and hook 'em.
Thank you for coming on stage. I'm looking forward to hearing more from students like you. Good luck, guys.
Thank you.
Thank you.
Thank you.
So for the last 40 minutes, you saw how NI envisions data and physical model-based systems working in synergy to add value to our customers. We look at testing and measurement as leading indicators of digitized industrial process progress. As we talk more about bringing the virtual and the physical world together, Charles, I'd like for you to just look into your crystal ball and see how you think all these things are beginning to come together.
Crystal balls are a little bit dangerous, aren't they? I think today for many of us, if you're like me, you're doing an increasing amount of your design in the virtual world, but the majority of your test is still in the physical world. And so how are we going to bridge those two things together to make this vision we've been talking about a reality? And what I would postulate to you guys is that measurement data is that key bridge. Because measurement data is a virtual representation of an actual physical phenomenon. And as we continually improve our models in the virtual space with real-world measure data, we'll be able to increasingly interact with our products in a cyber-physical world, just like we do when we interact with our prototypes today in a purely physical world. Just as Tony Stark designed the Iron Man outfit, or costume, what is it, a suit? I don't know what it is. In the popular movie Iron Man, aircraft engineers will be able to increasingly design their products in an immersive virtual world with a real model fed by real-time measurement data, and to be able to interact and optimize and refine that engine as it flies on the aircraft at 40,000 feet, but in a virtual space. That same technology is already beginning to ensure the safety of us all as we begin to adopt and test more fully autonomous vehicles. And you can imagine extending that to the factory of the future, where you could design and interact with all of the operators on the floor, all of your production equipment, all of your test equipment, and fully optimize your factory for yield, for cost, and for quality before you ever break ground.
Now, this is an interesting future which is nearly here, because what you've described could be hooked into the Omniverse, NVIDIA's real-time reference development platform for 3D simulation and design collaboration. There, we can use software constructs to bring the physical and the virtual world together. We can fine-tune the Omniverse using test and measurement data, so the Omniverse is made like the real world. In today's hyper-connected world, where we collaborate more and more digitally, this ability to create the virtual world and subject the virtual world to the physical operating characteristics powered by test and measurement data helps you create high-performance products in the shortest time with the highest quality. All this starts with NI helping you listen to your data and physical models so that you can build high-performance products that bridges design, manufacturing, in-use, optimizing characteristics of your supply chain using insights from all these different sources to be able to bring this together. Join us in this exciting future of engineering ambitiously to help deliver this vision to you. Thank you, everyone, and we hope you enjoy the rest of the conference and the sessions. Thank you. And thank you, Charles.
Thanks, Thomas.